Hello, this is Mr. Stansbury. I'm going to take you through the notes on division by surds. At the end of this, you should be able to say I can rationalize the denominator using surds. All right, so with that, to rationalize the denominator is basically to get rid of all the irrational numbers in the denominator. Okay, so we can't have roots in the denominator is basically why we have to rationalize the denominator. For any fraction of the form b over the square root of a, we can rationalize the denominator by multiplying by root a over root a. So basically, what do we have to multiply this down here by to get it so that it doesn't have a root anymore? So since this is a square root, square a times a is going to be a squared, right? So if we do, sorry, if we do root a times root a, that's going to give us the square root of a squared, and then this square and the root will turn this into a, and we then no longer have a root in the denominator. All right, let's try some out. Write with an integer denominator, which is rationalize the denominator. So to get rid of that root 3, this is the square root of 3, so if we multiply that by another root 3, and if we put the denominator as root 3, we've got to make the top as root 3, because anything over itself is equal to 1. And you can multiply anything by 1 and not change it. So 2 times root 3 in the top is just 2 root 3. And then if you'll notice on the bottom, root 3 times root 3 is root 9, which is the same thing as 2 root 3. Square root of 9 is 3. And we have rationalized the denominator. Or we also have written the denominator with an integer. Okay, same thing over here. 15 over root 5. We're going to want to multiply by root 5 over root 5. The 15 root 5 gives us 15 root 5. 15 times root 5, sorry. Root 5 times root 5 is the square root of 25, which we hopefully know as 5. So we have 15 root 5 over 5. Now these two, like 15 and 5, we can divide those. We can divide that nicely. So let's do that. 15 divided by 5 is 3. So we just end up with 3 root 5. Okay, 15 over 5. Those will play together nicely. All right. For any fraction of the form c over a plus root b, we can remove the surd from the denominator by multiplying by the radical conjugate, it's called, which in this case is a minus root b over a minus root b. So basically what you do is you just find the radical in the denominator, and you want to, if there's two different, two terms down there, you want to switch the sign of whatever's in front of the root. Okay? So let's try one of those right after we take a look at a little comedy clip. Yeah, you just don't see that every day, a cat chasing a dog. But anyway, with example 8, write the following with an integer denominator. So this is where we got to do our rationalize our denominator. So what we got to do here is we got to multiply this by the conjugate. So it's 2 minus root 6, so we're going to do 2 plus root 6. And 2 plus root 6 here also. So 4 times 2 root 6 and 2 minus 2 root 6 times 2 root 6. So on the top, 4 times 2 is 8. 8 times root 6. 4 times root 6 is 4 root 6. So that's what we get in the numerator. And then in the denominator, we've got to FOIL this thing out, right? So 2 times 2 is 4. 2 times root 6 is 2 root 6. Negative root 6 times 2 is negative 2 root 6. And then negative times a positive is a negative. And then root 6 times root 6 is root 36. Okay, so now that simplifies. 8 plus 4 root 6 on the top. We'll leave that alone. But look, these 2 root 6's will cancel each other out. And we have 4 minus square root of 36 is 6. So we have 8 plus 4 over, 4 root 6 all over negative 2. So, a couple of things. One, you can't have a negative in the denominator, so we'd have to switch all those. But we can actually, the 8 and the 4 are both evenly divisible by negative 2. So let's divide both of those by negative 2. 8 divided by negative, here, how about let's rewrite this so that it makes a little bit more sense. So this is the same thing as 8 divided by negative 2 plus 4 root 6 divided by negative 2. 8 divided by negative 2 is 4. And then 4 divided by, negative 4. 4 divided by negative 2 is not positive, but negative 2 root 6. So that we have now rationalized the denominator. The last one here, we want to get rid of this root 5 here in the denominator. So what we got to do is we're just going to simply change whatever sign here is in connecting these two. So we'll do root 5 minus 3, and then a root 5 minus 3 here on the top as well. Just like we had 2 minus root 6, we changed it to 2 plus root 6. Okay, so now we multiply the top, distribute the 2 through to this top part over here, and we get 2 root 5. And then 2 times negative 3 is negative 6. And then on the bottom, we got to FOIL this out. So first, root 5 times root 5 is root 25. And then outside, root 5 times negative 3 is negative 3 root 5. Inside, 3 times root 5 is positive 3 root 5. And then the last part, 3 times negative 3 is negative 9. Okay, so nice part about this is whenever we do multiply by the conjugate here, these middle two terms should always drop out, and they do. So we simply end up on the bottom, we get root 25, which is 5, minus 9 on the bottom. But let's see, let's write at the top. Let's write our numerator back there again. So 2 root 5 minus 6, can't really do anything with that, but root 25 is 5 minus 9, so that gives us 2 root 5 minus 6 over 5 minus 9 is negative 4. Don't want to have a negative in the denominator, so we'll switch. Easiest ways is to switch all the signs, multiply top and bottom by negative 1, right? So we get negative 2 root 5 plus 6 all over 4. And then both of these top terms, actually all of these terms here are divisible by 2. We don't have to worry about the root, just the whole numbers on the outside. So negative 2, 6, and 4 are all divisible by 2, so we can simplify that by dividing all of these by 2. So we end up with negative root 5, or 1 root 5. 6 divided by 2 is 3, and 4 divided by 2 is 2. So we end up with negative root 5 plus 3 over 2. Okay? All right, that's all there is for a division by surds. If you have any further questions, please feel free to ask in class. Thanks.